Welcome to all of you on my channel Maths with Muneer. I hope you all are doing great and watching my videos. So today I am going to do another live streaming where we will be learning about integration by substitution, and not to be neglected, this is a third lecture on integration, and I am trying my best to make sure that before the exam students would be learning a complete course of this integration. So if you are new to my channel, then please don't forget to see the playlist that I have created for you related to the integration and also for derivation as well. So before starting this lecture, for those of you who let's suppose couldn't able to get some concept, then I would suggest them to please go through the playlist of integration, and it is important for you to have a sound background of those two videos that I have already created for you, since you can see that this is a lecture 3, and then you can come back to this video and then you can see how strong you are going to be. Okay, so let's begin with today's lecture. So let me know please in comments if all of you are watching this streaming, and if somewhere you have any trouble related to the voice or anything, you can let me know. Okay, so the first question that we are going to do in integration by substitution is basically about cot square root of x over square root of x and gf. Please keep in your mind that all of you are having your notebook and pencil with you, and try to note it down every single step so that it could give you a better understanding while you are solving things your own. Okay, before we start this lecture properly, why we use integration by substitution? If somewhere we feel that the integral of a particular function that we are going to take and we couldn't able to solve it out, then we try to use the substitution method so that it could be easier for us to evaluate it, and this is exactly what we are going to do over here. Remember, in integration by substitution, you are going to do the substitution which is making your question is easier. All right, so there are several substitutions that you can take for a particular question. You have to make it sure that you are going to take an easiest one. Now if I look at this integral carefully, I will be realizing that over here we have cot of square root x over square root x. Now the substitution that I am going to make in this question is basically, I will be assuming that let u is basically your square root of x. Whatever substitution you are going to do for your question, you have to take the derivative of that. Why? Because over here in the angle of cot we have x, and you see the integral is also related to the x. So if you are trying to change this x into u, so you have to make it sure that this x is also going to be u. All right, now what I am doing now, I am going to take the integration of this du over dx is equals to 1 over 2, and it would be x power minus 1 over 2. For all of you who really don't know that how I took the derivative of square root x, square root means that x is power 1 over 2, right? So once you are taking the derivative of that, you have to apply the power rule. So 1 over 2 is coming over here, and then okay, let me do this step for you. So it is basically x power 1 over 2 and d by dx. Okay, so once I am solving it, I'm taking the derivative, the power will come first 1 over 2, and then you will be subtracting 1 from the power. So this is going to become 1 over 2 x power minus 1 over 2. All right, so what I am going to do now, I am erasing this and I am writing it directly over here, 1 over 2, and x is in denominator. Okay, once we have power minus 1 over 2 over here and you try to shift it to the denominator, it's going to become square root of x. Okay, now since dx is over here, and I want to keep x on one side, 2 will come over here in denominator, 2 du, and dx will come over here, dx over square root x. All right, now this is what we have got so far. Now what I am doing, okay, so what I am doing, yeah, it's fine. Now what I am doing now, I am going to substitute all these things over here in my integral. So it's going to become integration cot square root x is basically your u. Alright, now dx over this square root x is equals to 2 du. Alright, dx over square root x, you are going to put 2 du instead of that. Now 2 du. So you see the substitution that I made in this question has make my question more simpler. So cot u 2 du. Now if the angle is u, now you see the derivative I am taking also with respect to u as well. So now you can take the constant outside, which is basically 2, and we have got cot u du. Alright. Now how about taking the integration of cot? We know that cot is basically the cos u over sin u du, right? Now I told you in my previous 2 lectures that if somewhere we are having a fraction, then we have to be very careful while taking the integration of a fraction. Now we can see that in denominator we are having sin u, which you can say that sin u is basically your function, let's say f of u, and now in denominator you are having the derivative. Alright, so in integral, while solving an integral, you are having a function in denominator and its derivative is present in denominator. So what you can do, you can apply the formula which says that natural log of sin u plus c. This constant of integration is very important. You cannot neglect it. Why? Because we are solving indefinite integral. In indefinite integral, the limits of integration is not given to you. So once you are having such type of integral, you must need to introduce the constant of integration, which is basically your c. Okay, you have to make sure that initially your question was in x variable, right? You are taking the integration with respect to x. Now you are ending up over here as u. So this is, you can lose 0.5 or 1 marks just because of that. So whatever substitution or whatever assumption you have made over here initially, you are going to plug in back. So 2 into ln of sine, this u will be basically square root of x plus c. So that's your answer. Alright, now you can, I am going to be on this side and I am seeing if you have any question related to it. On a meanwhile, you can note down this question and then we will be solving a next one. Okay, thank you for your appreciation. I always try my best to make sure that I am giving students a better understanding of getting concept. You know, while you are in your exam, then you might not be, you know, due to the stress or due to the pressure of exam, we often forget that what type of substitution we basically have to do in order to solve this question. So in this lecture, what I am going to do now, I will be solving one question with different method, and I will try to make you understand that how you will be able to know that you have taken the wrong substitution, or maybe you are using the wrong substitution. Like I said initially in my lecture, that the purpose of solving integration by substitution is that basically to make sure that you are making your question easy. If your question is becoming more difficult than initially, it means that your substitution is basically wrong. So I hope that you have noted down this question. So now I am going to erase it, and then we will be solving another one. Please keep on asking several questions in comments in chat box, and I will try my best to make sure that of answering all those questions. Okay, now another question is x square root of x minus a dx integration. Okay, now we can solve this question by using the integration by parts, but since I have started integration and it's my third lecture on integration, so we haven't know yet that how basically integration by parts we are going to apply when we have two functions in one integral, right? Integration by part is basically the product rule, like you can say we often apply on derivative. Okay, now integration by part is a product rule for integration. Now in this question, this is x into square root of x minus a dx. So we have to make a substitution over here as well. All right, now I will be solving this question in two ways, and then I will be telling that why and how you will be able to know that what type of substitution you have to use. Okay, let's suppose that I am taking x is equals to t. All right, let's suppose that I am taking x is equals to t over here in this integral. I said in my previous question that whatever substitution you are going to take, you got to take the derivative of that substitution as well. So over here I am taking the derivative of x with respect to derivative with respect to x. So over here we are going to 1, derivative of x with respect to x is 1. So derivative of t with respect to x is going to become dt by dx. Now this dx can go to that side and dx will be equals to dt, right? Okay, now I want you to plug in all these things over here. We said that x is equals to t, so you can write t, all right, and now square root of x is what? T minus a, and in dx dx is equals to dt, so I am going to write dt. All right, now I want you, the reason why I have wrote this two integral is that so you can make a comparison. I told you that the purpose of doing the substitution is that to make your question is easy. Now compare these two results. Nothing happened. We have converted x into t and the integral remains the same. So it means that the substitution that we did in this question is wrong or isn't able to give us what we actually looking for. So what do we have to do now? It means that we have to change the substitution, right? So it means that we have to change the substitution. Okay, so I hope that you are getting the concept and you are knowing that how we are going to take the substitution. Now I am assuming that solution, let x minus a is basically equals to t, right? X minus a is basically equals to t. So now from here I am going to take the derivative of this. So derivative of x with respect to x is going to be 1. A is constant. So derivative of constant is equals to 0 and derivative of t with respect to x is going to become dt over dx. Now shift dx to the other side, it would be dx is equals to dt. Now we can put x minus a as equals to t according to the substitution that we have made, and we can, by looking at this result, we can put dx is equals to dt over here, but yet we have a problem. What problem we are having? I told you that over here we are having the variable is basically x. So you see all the integral, in integration you are having x. So if somewhere I am converting x into t, so it means that all my values should be in t. Okay, this square root is going to convert into t, this is going to be t, but here we still have x. So what does it mean by that? From here we have to get the value of x. So x is going to be, a will go to the other side, so t plus a. So now we can put this x is t plus a and square root x minus a is equals to t, and in dx you can put dt. So this is the integral that we have got now, and this is what we are going to solve now. Now you see we have converted our integration into this form. Now it seems more easier for you to understand it, and that does making sense, and it seems like we are successful with this substitution that we have taken over here. Now you can multiply this square root t to this bracket, which is very easy. We know that t over here power 1 and this t have power 1 over 2. Once this t is multiplying with that square root t, it's going to become t 1 plus 1 over 2 will be 3 over 2 plus a into t 1 over 2 dt. There is nothing difficult that I did in this step. What I did actually, I just multiplied these two, and here you have integral as well. Okay, and this is the form that we have got now. Okay, since in my previous two lecture I shared with you that we are going to apply the integration exactly the way we have applied the derivation. So we are going to separate this integration, and we will be getting integration t power 3 over 2 dt plus a is constant, you can take that a out, and t power, this is 1 over 2 and this is your dt. Okay, now solve this. Alright, now solve this. So over here t into 3 over 2 plus 1, we are going to apply the power rule of integration. So 3 over 2 plus 1 will be 5 over 2, and in denominator we will also be having 5 over 2, and that 5 over 2 is going to convert into 2 over 5 plus a, and t 1 over 2 plus 1 will be 3 over 2 over 3 over 2, and that will be 2 by 3 plus c. Now from here on we can write it as 2 over 5 t power 5 over 2 plus 2 a over 3 t 3 over 2 plus c. Now what next? Remember, we have made this substitution in order to solve this question. So what we are going to do now, we are going to put our substitution back. So x minus a was equals to t, so put the value 2 over 5, t is x minus a and 5 over 2 plus 2a over 3, t is x minus a 3 over 2 plus c. Now if you are leaving this question over here, that is fine, there is nothing wrong in that, you will be still getting the proper marks. But if somewhere you wanted to simplify this question, you can still do that. And the reason how we can do that, by making the denominator same in this question. So here we have 5 and here we have 3. So in order to make these two fractions same, it means that I will be multiplying with 3 in numerator and denominator, and here I will be multiplying with 5 in numerator and denominator. Since I am multiplying with 3 over here, so that's going to become 3 times 2 is 6 into x minus a 5 over 2, and 5 times 3 will be 15 plus, here I am multiplying with 5, so 5 times 2 is 10a, 5 times 3 is 15 into x minus a 3 over 2 plus c. Okay, what we can do now, I'm trying to be at this side, so that if somewhere you are noting down this question, make sure that you are noting every single step. Okay, now let's see if somewhere till here you have any question, so that I would be able to respond to those questions. Okay, now I am erasing this part. Now you can take 2 over 15 common, 2 over 15 you can take common, and you can also take x minus a 3 over 2. Here we have x minus a power 5 over 2, and here we have x minus a 3 over 2. So we can take x minus a 3 over 2 common. So we got left 3 into x minus a, since 3 over 2 plus 1 makes 5 over 2. Remember, while when you are taking x minus a 3 over 2 common, so over here we are only left with 3 into x minus a plus we have taken 2 out, so this is 10, so it means we got 5 here, and there is also a plus c. Okay, now let's simplify this. So it's going to be 2 over 15 into x minus a 3 over 2, 3x minus 3a plus 5a plus c. So you can write it as 2 over 15 into x minus a 3 over 2, 3x minus 3a plus 5a will be plus 2a plus c. So that's your answer. Okay, so you can note this down. Please keep asking if somewhere you have any question. On a meanwhile, let me set the camera if it is perfectly fine. Yeah, I think so. We have enough space on the other side, so if somewhere I wanted to do, I can write it on that side. All right. Okay, so I am erasing this one. You see, I have solved this question. Let me give you a quick overview of what I did in this question. In this question, I tried to do the two substitution. All right, in this question I tried to do the two substitution, and you have seen that the first substitution that I have taken in this question wasn't working at all. So that's why I did the another substitution. So please, while you are in your exam, don't try to be confused, just try to go with the basic and make yourself aware of that. The purpose of doing any kind of substitution should make sense, that it's going to make your question easier. Now we are having another question, which is cos into, in angle we have square root x minus x over 2 multiply by 1 over square root x minus 1 and dx, and here we have integration. Okay, now we are going to solve this question. Again we have to use the integration by substitution. Now we have two things over here, one is in the angle and the other thing is multiplying with the trigonometric function is cos. So either we can take the substitution this or this. So what I am going to do now, I am going to take the substitution u, let's say u is equals to square root x minus x over 2, and let's see what we are ending up as a result. Okay, whatever substitution you have taken, you have to take the derivative of that with respect to x, right, equals to, now derivative of square root x will be 1 over 2 times square root x, right. X has a power of 1 over 2, okay, x have a power of 1 over 2. Once you are applying the power rule, you are ending up with this derivative. Please make sure that these are very childish steps that I have explained over and over and over again. So while you are in your exam, try to save as much as time you can. So if somewhere you feel that there are a couple of questions that might need more of your attention and that they might need some extra time, so you are not wasting steps, all right. Whoever your examiner is going to, if you are doing this step directly and you are writing the derivative of square root x as 1 over 2 times square root x, the examiner will be able to know that yeah, this kid have a concept and he properly wrote the exact derivative. So we are not expecting from you to do every single step. Try to save as much as time you can wherever it's important and necessary. And x over 2 will be as 1 over 2, right. Okay, so what I am going to do now is shifting dx to the other side. I am taking 1 over 2 as common, 1 over square root x minus 1, and we have got dx over here, all right. So if I am keeping 2 over here, that's fine, but I am going to move it to the other side. So 2 du is equals to 1 over square root x minus 1 into dx. Okay, so now what we have got here, so integral cos, this whole thing was u, so I am going to put it back, dot multiply or dot both have the same meaning. Now if you look at this thing, it's equals to 2 times du, so we can write instead of that equals to 2 du. Now you see, now look at these two integrals, this one and this one, and you will be realizing that yes, your question have become more simpler than it was earlier. So you can take 2 out and then you can write cos u du, you can write 2, and we know that the integration of cos is integration of cos is basically a sine, so you can write sine u plus c. Not to be neglected, integration of constant is very important since we are solving indefinite integral. Now 2 times sine, what was your u? U was square root x minus x over 2. So this is the time now where I am going to put it back, our substitution, square root x minus x over 2 plus c. So this is your answer for these questions. You can note it down. Okay. All right. So we can erase it. Let me see if stream is working perfectly fine. Yeah. So please keep liking this streaming and let me know your valuable feedback, because your valuable feedback is really means a lot to me, and this is why honestly I am trying to put all my efforts to make sure that you guys are getting the right concept and are not afraid of maths anymore. Okay. Now the next question that we are going to solve now is integration secant square x over square root of tan x dx. Okay, now sometime it might be possible for you, if you really have prepared yourself for your math exam, then might not be examiner is asking you to use the integration by substitution, but sometime they might can give you a free hand that solves this integral where you are not bound to use any method. What do I mean by that? I mean, we can solve this question into multiple ways, right? So if they haven't bound you, so it means that you are free to use whatever method you feel that in which you are comfortable. Now I am going to solve this question with two methods, and I will make you sure that you are getting both these methods. So the first of all, since we are learning about integration by substitution, definitely I am going to do that, but with first I am going to use the another method that I have shared with you in my previous two lecture of integration. Now we know that if you look at this fraction carefully, you will be realizing that the derivative of tan x is present. If you exclude this square root, alright, the derivative of tan is basically secant square x. So derivative of tan x is present in numerator. So it means that you can apply the natural log? No. Why? Because there is a power of a function, right? You can take the derivative if in a fraction we have function f of x in denominator and its derivative is present in numerator, then very easily you can write ln of f of x plus c, then you can solve it like that. But over here you have function f of x which is tan x, but there is a certain power of square root, alright, but since there is a power which is square root, so it means that we have to do something additional in order to solve these questions. Okay, now what we can do now, I am shifting tan x to the numerator, writing as 1 over 2 multiply by secant square x gx. Now the derivative of a function is present, alright, and we have some power of function, so it means that we can apply the power rule, which is tan x into 1 over 2 plus 1 over 1 over 2 plus 1 plus c, and that's going to become tan x. 1 over 2 plus 1 will be 3 over 2, and that would be 3 over 2, and 3 over 2 will be converted into 2 over 3 plus c. So that's the one method. So that's the one method in which we can solve this question. Now let's do the substitution method. Okay, the same integral secant square x over square root of tan x into dx, right? Now I can use the integration, let u is equals to tan x, let u is equals to tan x, and the reason why I am taking tan x, because if we take the derivative du over dx, we are taking the derivation of u with respect to x, so the derivation of tan x is secant square x, right? Derivation of tan x is secant square x. Now dx will go to the other side, or we can say that over here we are separating things. Okay, u we are keeping on one side and x we are keeping to the other side, so that will become secant square x dx. Now if you look at the integral initially, secant square x dx, okay, it's equals to du, so you can write du over in tan x is equals to u, and then there is square root u. Okay, we can shift this denominator into the numerator and it would become minus 1 over 2 du, right? So while solving this integral, we have to apply the power rule of integration, which says that n plus 1 over n plus 1. So it would be minus 1 over 2 plus 1 would be 1 over 2 over 1 over 2, and I can write it as 2 plus c. Now not to be neglected, you have to put your substitution back. So 1 over 2 means square root, and u was equals to tan x plus c. So let me see if somewhere we are getting the right answer. Oh, so we made a mistake over here, right? So once we shifted this square root to the denominator, 1 over 2 is going to become minus 1 over 2, and then minus 1 over 2 plus 1 would be 1 over 2, and minus 1 over 2 plus 1 would also be 1 over 2, and that can be written as 2 into, you see. Okay, now if you look at both these answer, they are exactly same. Okay, we can write it as tan x plus c. So this is your answer. You can note it down. Okay, now I am going to erase this one, and we are going to solve another question, which is okay, the next question is integration cos x bracket ln of sin x over sin x dx. Alright, now please do not cut this sin x with that x, alright, because in the angle of natural log we have sin x, so you cannot cancel this sin x to that sin x. Now we have to solve this question, and let's see how we are going to do now. Okay, what we can do now, we can solve this question again with the two methods. Alright, we can solve this question again with the two methods, and we will be doing them both again in the comparison, one over here and one over here, so you will be able to identify that which method is easier for you. Remember, you need to learn your maths in a such a way that while you are in your exam, whatever method is coming into your mind, you are going to go with that method. Alright, so do not try to make sure that you are remembering all the methods. Alright, practice them well. So we can write cos x over sin x over here, and then we can write ln of sin x dx. Okay, since we are learning integration by substitution, so first of all I am going to use the substitution method here for you. Okay, or let's do the other one first. Okay, now look at these two functions carefully, and you will be seeing that the derivative of ln of sin x is what? Ln of sin x, this derivation of ln of x is always 1 over x. So it means that the derivative of ln of sin x, it would be first 1 over sin x, and then we have to ignore the ln, and we will be only taking the derivation of its angle. So the derivation of sin x is cos x. So it seems like, in fact, it is, the function is over here and its derivation is present over here, like I have explained it to you over here. Okay, now we have function and we have its derivative present together, and both function and its derivative are multiplying with each other. So in that case, we can simply apply the power rule of integration, which is, we can apply the power rule of integration on the function part, and it would be ln of sin x 1 plus 1 over 2 over 2 plus c. That's it, right? So you see how easy it is for solving these questions if you properly doing it with the concept. Now I am solving the same question with with the substitution method, and I'm writing this form first. Okay, cos x over sin x multiplied by ln of sin x and dx. What now? Okay, so we are learning integration by substitution, and we are going to do the substitution. Let u is equals to ln of sin x. Now take the derivative with respect to x on both sides. It would be du by dx, and derivation of ln of x is always first 1 over x. So we can write 1 over sin x multiply, then you ln of x, we have taken the derivation by including the ln, then you have to ignore ln and you have to take the derivation of its angle. Now in the angle we are having sin x, so the derivation of sin x is going to be cos x. Okay, separate du and dx, then we can write cos x over sin x, and dx is here on this side. Now you see, so let's rearrange our integral. We can write ln of sin x multiply by cos x over sin x into dx. Okay, so the substitution was u is equals to ln of sin x, so we can write u multiply, now cos x over sin x into dx, that whole thing is equals to u. So instead of writing that, we can write du and it would be this. Now integration of u, simply apply the power rule, it would be u square over 2 plus c, and then you have to plug in the value of u back. So I am going to write it here. What is u? U is ln of sin x. So ln of sin x squared over 2 plus c. So this is our answer. Now you can match these two answers and you can see that both the answers are exactly the same. So no matter from which method you are going to solve your integration, it will always be ending up with the same answer. Okay, please note it down, and then we can solve another question. Okay, the next question is x plus b over x square plus 2bx plus c power 1 over 2 into dx. Okay, again we can solve this question with the two method, and I am going to solve it with the one method and the integration by substitution. So since this is the concept, I am going to solve it with another method, and I want you to solve this question by the substitution method, and let me know in comments or chat that whether you are able to get the right answer or not. All right. Okay, now let's solve this question. Again, if we look at both these thing, numerator and denominator, we can see one thing very clearly, that the derivation of this is going to be what? Derivative of x square is 2x and derivation of 2bx is going to be 2b. So we have everything present in numerator except 2. So in order to do that, I can divide and I can multiply with 2. Okay, so x square plus 2bx plus c power 1 over 2 and dx. So 1 over 2, I can shift this thing to the numerator, x square plus 2bx plus c power 1 over 2 times 2x plus 2b into dx. Now function and its derivation both are present, and we have the power of function. So while solving the integration, we can simply apply the power rule which says 1 over 2 plus 1 would be 3 over 2, and 3 over 2 will become 2 over 3, and then we have plus c. Do not be confused in that this c was already present in the function, and this is the constant of integration that we have used. So if you wanted to differentiate both of them, you can write c1 over here. So 2 with 2 cancels, so 1 over 3 into x square plus 2bx plus c power 3 over 2 plus c1. So this is my answer when I have solved this question with a simple way, like we have learned in my previous 2 lectures. So I want you to solve this question with the integration by substitution method, and let me know if somewhere you are getting the right answer or not. I can help you out if somewhere you are not getting the right answer. So thanks to all of you for being with me with this live streaming. So we will be doing another live streaming on integration by substitution. The part 2 will come soon. Thank you.